Hi everyone, I hope you're doing well and welcome back to the AI Tech Explain Right channel, a place for AI professionals and enthusiasts to stay updated with AI advance. In this video, I will show you how to build your own custom Llama 3.2 by fine-tuning it using ONSLOTH. To do so, we will walk through this official ONSLOTH notebook made available by ONSLOTH team. In the notebook, we will see how to prepare data, train a model, run a model, and finally how to save it. I will put a link to the notebook in the video description. And as mentioned in the notebook, you can run it using a free Tesla T4 Google Colab instance. So first thing first, let's start with installing ONSLOTH by running this cell. Second, we need to import fast language model class. The class is used to load the model and the tokenizer. Here we choose Llama 3.2 3 billions instruct model, which is a light model that can be run even on a small device. And we set max sequence length, the type, and loading 4-bit variables to values that we set in the beginning. We have to set the Hugging Face token as well. If we use gated model like MetaLlama, llama2 7 billion Hugging Face. Now, if we go back to variables that we've set in the beginning, we see that the max sequence length is set to 2048. You can take a look at your training data as well to check the longest sequence and set the max sequence length based on it. But any value is acceptable here as rope scaling is supported internally. For the type, it can be fixed to float 16 or float 8. Otherwise, if none, the value is detected automatically based on your hardware. Now, the load in 4-bit quantization is set to true to reduce memory usage. Once you run this cell, you will see this beautiful message where you see the used GPU, PyTorch and CUDA versions and the model and the tokenizer loaded. Now we add LoRA adapters. We are not applying a full fine-tuning here. We only need to update 1 to 10% of all parameters. To do so, we precise the different modules that are targeted. These modules are trained separately and merged later with the original module weights. Also, you have to set the rank, which determines parameters in LoRA adapters. Higher is better. LoRA alpha defines the impact of LoRA adapters when merged with the original module's weights. The LoRA dropout is like dropout in general, is used for regularization by zeroing elements during the training. The bias is set to none, means that no additional bias will be added to the model components being modified. For the use gradient checkpointing, we set the ONSLOTH for very long context. The random state ensures the reproducibility to be consistent over runs. The rank stabilized LoRA or RS LoRA is set to false here, which means that we use the original scaling factor. The LoftQ config is the config related to quantization. Now let's talk about the prompt template in the dataset that will be used in the fine-tuning. As we use the instruct version of Llama 3.2, we need to use the Llama 3.1 format for conversation style. So we need to use the role content format instead of the from value format, which is the original format of the dataset that we will use in fine-tuning as you see here. To do so, we will use the get chat template from onslaught.chatTemplates and passing the tokenizer and Llama 3.1 chat template as parameters. After that, we use this tokenizer to convert conversation into the good format, and we use this conjointly with standardized ShareGPT to move from this format to this format. Now, if we check one of the examples here, we see that we have content role format now. And here is how chat template transformed these conversations by adding tags. It's to be noted, guys, that Llama 3.1 instructs chat template by default adds cutting knowledge date, December, and so on. So don't be alarmed. Now, enough preparation, and let's go to train the model. To do so, we will use the SFT trainer class, which stands for Supervised Fine-Tuning Trainer from Hugging Face TRL package. Obviously, we pass as parameters the model, its tokenizer, the dataset, which fields of the dataset we will use, and the max sequence length that we defined in the beginning. Also, we set data collector that will be used, the dataset numproc for processing the dataset, and packing. Now, if we go directly to training arguments, we have for numtrain epochs, if we set it to 1, a full training will be run, but here we set max steps instead, as the dataset is big enough, and the total number of steps is defined by per device train batch size. For example, here it's set to 2, so each step is training on 2 examples from the dataset. Now, the learning rate is kind of the pace of learning. If it's big, the training will be faster, but the model might not converge to the optimal solution, and vice versa. Gradient accumulation steps, when set to 4, means that after 4 steps, the gradients will be summed up. Warm-up steps defines how fast the learning rate is increased during training. We set FP16, BF16, and logging steps. We use Adam W8-bit as optimizer. The weight decay is a parameter used for regularization to avoid overfitting by adding a penalty to the loss function. LR scheduler type is set to linear. And finally, we fix the seed and precise the output rate. So this is it, guys, for the training parameters. Now in this cell, we specify that the training should be evaluated only on the assistance output and that the user's loss should be ignored. Now here what we are doing is that we are masking system and instruction prompts. Here we are showing some memory stats like max memory and reserved memory. And congratulations, guys, because you made it till this point. Now we are ready to launch the training. We do so by running trainer.train, and we see here in the beginning a message showing different chosen parameters. We have a message that talks about logging into 1db.ai. I might create a separate video dedicated to 1db, guys, which is a tool for tracking and visualizing machine learning experiments. Now here we see the training evolution. As you notice, the training loss is going up and down. It's constantly going down and it's not necessarily stable at the end. This can be improved by playing with parameters like batch size, learning rate, and other parameters and see how it goes, but this depends on the hardware as well. Here we see final memory stats like total time for training, peak reserved memory, and so on. Now we are ready to use the model for inference. To do so, we need to run model.generate by passing inputs along these parameters. And in the inputs, we have the user inputs and the same tokenizer used in the beginning. And here we have the output where we have again the system message, but we can mask it again. And we have the model answer to the user's request. We can do the same in streaming mode to see generated result token by token instead of waiting till the end. Now, obviously, at some point, we want to save the model. To do so, we can either save it locally this way or push it to Hugging Face Hub this way. And it's to be noted, guys, that here we are saving LoRA adapters and not the full model. Now to load the LoRA adapters we've just saved, we just need to put this block in red under true instead of false, and the rest is kept the same. Also, you can use Hugging Face auto model for parameters, efficient fine-tuning causal language model, kind of very long name. Fortunately, we have the abbreviation. As mentioned here, use this if you do not have UNSLOTH installed to avoid slow behavior. Also, saving float 16 and int4 directly is supported, and LoRA adapters are allowed. We can store the GGUF version of the model as well using safe pre-trained GGUF or push to hub GGUF with different supporting quant methods. So this is it, guys, for this video. Here you have a list of interesting notebooks. I'm planning to cover some of them in other videos. Stay tuned to my videos if you're interested in them, or let me know in the comments if you have any preferences. And in the next video, I will show you how to run the fine-tuned model locally using Ollama. Thanks guys for watching. I hope you liked the video. Don't hesitate to put thumb up if it's the case. And please don't forget to subscribe to the channel to have more videos like this one. Don't hesitate to put a comment if you need more details or on any concept about which I talked so far, and see you next time.